All right, so this is your final review for the Unit 11 test. I highly recommend that you pause this video and do all the problems on your own and then check your answers using the video. That way you can figure out what you understand on your own and really closely pay attention to the problems that you were struggling with. All right, so let's look at problem number 1. Let f of x equals 64 to the 1 over x and find f of 3. So since this 3 is in the parentheses, just like the x was in parentheses here, that tells me that we're thinking, what is the value when x equals 3? So f of 3 replaces the x here, equals 64 to the 1/3 power. Well, when I look at this, the first thing I think is I could just turn this into a root, right? So this would be the 3rd root of 64. So I would need to be thinking, what number times itself 3 times would give me 64? And that would be 4, right? And we could always double check it in our calculator. But, so we could go ahead and clear it out and type in, okay, what is 4 to the 3rd power? 4 to the 3rd power is 64, so I know that is correct. So f of 3 equals 4 is our final answer for this one. You could also type it in just 64 to the 1/3 in parentheses. Since this works out nicely, that is okay. Next one says evaluate log base 1/2 to the 1/32. So we're going to want to change. We're going to want to change this one, right? So the idea is 1/2 to something should equal 1/32. So 1/2 to some power equals 1/32. All right, well, since my numerators are the same, all I really have to worry about is my denominator here. So does 2 to some power give me 32? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So yeah, so my question mark is really 5 because it took me 2 to the 5th power to get there. So 5 should be your final answer. Okay, so let's look at number 3. This one is asking us to solve. So if I'm going to find the value of x, the issue here is that x is inside the log and we have an equal sign here. Whenever we have x inside of a log, we need to get it out of the log in order to solve. In order to get it out of the log, remember you're going to have to change it to the other format, which in this case is exponential. So because there's no base written here, remember that that's the common base, which is 10. So this means 10 to the 3rd power equals 2x. So now we have a problem that we can solve because 10 to the 3rd, 10 times 10 is 100, times 10 is 1,000, equals 2x. And then we can go ahead and divide by 2. So we get x equals 500. Okay, next one. Evaluate log base 3 of 2.75 round to the 4th decimal place. So at first I would be thinking 3 to some power equals 2.75. But because this is a decimal, and 3 to some power isn't going to equal a number that's smaller than it, I'm going to forget about doing that. And the other hint is that it tells you to round. If it tells you to round, that means you're going to get a decimal, which means you're going to have to use your calculator. So that tells me that I just need to do the change of base formula, which means log of 2.75 over log of the base, which in this case was 3. And then I need to just get out my calculator and go ahead and type that in. So log of 2.75 divided by, and remember to close your parenthesis before pressing the division, divide by log base 3, close my parenthesis, gives me 0.920798. Now, our instructions said to round to the 4 after the decimal, so 1, 2, 3, 4 would be here. So this 9 would make that 7 become an 8. So it's 0.9208 as your final answer for number 4. Okay, next one asks us to solve again. Now, if I'm going to solve, that means I have to get x alone. The issue is x is in the exponent. So I can't solve for this because x is in the exponent. I need to get it out of the exponent. So to get it out of the exponent, we change to the other format, which means we need to change to a log. So this is log of the base, which in this case is e, log base e of the answer equals the exponent. Now, as soon as I see log base e, that should remind me that I really need to change that to the natural log. So really, it's ln of 5 equals 2x plus 1. And then I can get x alone, so I'm going to subtract 1 first. So I get ln of 5 minus 1 equals 2x, and then I can divide by 2 to get x alone. So x equals ln of 5 minus 1 over 2. Now that's the exact answer, but to get an estimate, we would need to type it in our calculator. Now remember, when you go to type this into your calculator, you're really going to type the top in, press enter, and then divide by 2, or you're going to use the fraction button. So I'm just going to do it without the fraction button. So ln of 5 minus 1, enter. And then I'm going to take that number, and that's why I just pressed divide it, because it shows the answer, divide it by 2, gives me x equals 0.3047. Depending on whether you're asked for an exact answer or an estimate, those would be your two answers that you would have. All right, on to the next page. Looking at number 6 first. It asks us to write log of x squared minus 7x plus 12 minus log of x minus 3 is a single logarithm. In other words, they're asking us to condense it. So if I see subtraction between it, subtraction really means division, right? So this is really log of x squared minus 7x plus 12 over x minus 3. Now this is as condensed as we think it can get, but we need to simplify this if we can, which means we need to factor this top one in order to simplify. So since there is no GCF and my first term is 1, all I have to think about is what multiplies to the last, which is 12, and adds to the middle, which is negative 7. So 12 is 1 and 12, 2 and 6, 3 and 4, and if I make both 3 and 4 negative, that would give me a positive 12 and add to negative 7. So this is really log of x minus 3, x minus 4 over x minus 3. And because we have a common factor on the top and bottom, they cancel out, leaving me with log of x minus 4 only as my final answer. All right, next one. They ask us to solve this one, and we know we can solve because it's an equal sign. If there weren't an equal sign, we couldn't solve, but there is, so we need to. Now, the first issue I see here is that we have multiple logs on both sides, so we're going to need to condense each side first before we can solve. So we're going to condense it by putting them together. Now, in this case, there's a plus sign, which tells me I'm going to need to multiply them. So really, this side is log base 3 of 2x times x plus 1. So then I can distribute this in to get 2x squared plus 2x and log base 3 of that. So now this side is condensed, and it will equal whatever I get when I condense this side. Again, it's addition, so that means we're going to multiply them. So we're going to do log base 3 of 2x plus 3 times x minus 3. Well, that would give me 2x squared minus 6x plus 3x minus 9. And then we can combine those to say that this side is really log base 3 of 2x squared minus 3x minus 9. Now, the next step is to try to actually solve this. And since we have the logs with the same bases, that means that what's inside them has to be the same as well. So we can just get rid of that and say 2x squared plus 2x has to equal 2x squared minus 3x minus 9. So now my goal is to get everything together. So I'm going to move my 2x squared over by subtracting it. which really means that these just cancel out, leaving me with 2x equals negative 3x minus 9. And since now there's only the x terms, there's no x squareds, I know I don't need to factor. If there was an x squared and an x still left, I would need to factor, which means it would have to equal 0 before I could do anything else. But since there's only an x term, we can just get x alone by moving my x's together. So I'll add the 3x, and we get 5x equals negative 9. So we get x equals, we would divide by 5, so it would be negative 9/5. Now we should check and see whether or not that actually plugs in to give us positive numbers on the inside. So 2 times negative 9/5 would be a negative number, so that means that's an extraneous solution, because it would be 2 times negative 9/5 would give me a negative number, and we can't have a log with a negative number on the inside, so my answer really is no solutions. Okay, let's look at number 8 now. Number 8, if $895 is deposited in an account that pays 7%, compound it continuously. So as soon as I see continuously, I know my formula is A equals P, E to the RT. So that means I need to know what's my A, what's my P. E is a number, so I don't have to worry about it. What's my R, what's my T? So deposit is the principal. It's that starting amount that you have, so that's my P. This 7% is my rate, so it's 0.07. Then what amount will be there after 4 years? So my T is 4. So now we can just plug all that in. A equals 895 E to the 0.07 times 4. So we can go ahead and plug that in. 895 E to the 0.07 times 4 would give me 1184.201. So that stays a 0 because 1 keeps it there. So then we need to write a sentence. So then what will the amount be in 4 years? So in 4 years, there will be $1,184.20 in the account. Now, if they were asking us how much did they make, that is not how much money they made, that's how much is in the account. We would need to subtract that to figure out how much they actually made. Okay, so we're going to do the last two for this page. It's an equal sign, that means we need to solve. If there were exponents on both sides, I would try to make the bases the same, but since there's only one exponent, the idea is, since my variable is in the exponent, I need to get it out of the exponent, and the way you get it out of the exponent is to change it to the log format. So log of the base, which in this case the base is 4, so log base 4 of the answer, which is 9, equals the exponent. Now in order to solve this, I would need to be able to find this. So we're going to do the change of base on this first. So log of 9 over log of the base, which is 4, equals x plus 7. So now we can go ahead and type that in our calculator. So log of 9 divided by log of 4 gives me 1.5849 equals x plus 7. Then I'm going to subtract 7 from it. Now, when you do this, leave that in your calculator so you get the most exact answer and just press minus 7. That tells me that x should equal negative 5.415. Okay? And the last one for this page. Now, when I look at this one, you should notice that there are actually two exponents here, right? And there's variables in both of them. So that means I cannot do just changing it to the log. Instead, I need to make the bases the same. So because two exponents with variables, we need to make the bases the same. If there was just one exponent with a variable, we wouldn't need to do that. But since there's two exponents, both with variables, we need to make the bases the same. So since this is 16, I'd be thinking, does 16 to any power give me 64? And the answer is no. But 4, let's see, 4 squared is 16, so that works. And I believe, no, sorry, 4 times 4 is 16. Yep, so we can do 4 as the base for both of them, because 4 to the third power is also 64. So I'm going to make my base 4. So 4 to what power is 16? 4 to the second. And then we still have the x minus 2 on the outside equals, we're going to make the base 4 here, but since my number's in the denominator, my exponent has to be negative. And then we said 4 to the third power is 64, so 4 to the negative third would be 1 over 64, and we still have that exponent there. Now that we have our bases the same, if our bases are the same, we can set our exponents equal. But remember, exponent to an exponent means we're multiplying, so this is really 4 to the 2x minus 2 equals 4 to the negative 3 times negative x would be 3x. So bases are the same. We set them equal to say 2 times x minus 2 equals 3x. So that'd be 2x minus 4 equals 3x. Subtract our 2x. And we get negative 4 equals x. Now remember, with these, you can always plug it back in to check to see that you get the same answer, right? So I can do 16 to the x, which is negative 4 minus 2, and see what we get as our answer. And then this one was 1/64 to the negative of x, so negative 4. We get the same answer, so that tells me, yes, I was right. And we can even check this one as well, although this one will be more difficult because we had to estimate. Okay? Now you'll have to go to the next video to see the rest of it, the rest of this review.